Hey everyone. So I'm gonna continue learning C++ today. Um, so last Saturday we worked on um, like we learned how to declare variables. We also learned that there is like some weird side effects that happen in C++ when you try to use a variable that is not that hasn't been initialized. So today we are gonna be continue using the same like website or book that we received before. So it's learn C++. Uh, or so the goal for today is to do chapter 2, which is about functions and files. So that's kind of what we're going to be learning today with the part of the stream. So we are going to just walk through the like the tutorials and figure out like things that we have to learn about the language itself. And again, the goal of me learning C++ is to be able to write a libs parser. So I wrote one before using Go. So the goal is to take that and convert it into a C program, and then we could use that to also learn LLVM. So I have an interest on learning how LLVM works. So the goal is to take this what we learned from here to then create an interpreter for libs in C++, and then take that interpreter and start using LLVM to produce assembly code that could be run on Linux, for example, or in a Mac. So that's kind of what we're going to be working on. Cool. So let's get started. So, okay, so we're learning about functions. Okay. So yeah, so we defined some functions, but we didn't really explain what they were. So now we're going to be learning more about them. Cool. Okay, so sorry, I'm having a bit of an issue with Twitch right now, so I'm just refreshing my dashboard to make sure that everything's working correctly. Okay, cool. Because I use the Twitch dashboard to check the chat and also check how the stream is doing. So I just have to make sure that things are correct. Yeah, there we go. Cool. So we so we're learning about functions. We're making sure that how they work correctly, how you define them. So we have two functions here. We have doPrint and main. So these are two functions that you could run. And it's kind of like explaining what the function itself doing. And then different like how functions could be called twice. Sorry, more than once. And then like functions calling functions. Nested functions too. So I see. So you cannot really nest functions. Cool. And again, we're not doing the quizzes themselves. We're not answering the questions. But it's interesting that they're showing this example here, which doesn't really work. But it's kind of cool that you cannot do that. So I wonder if there's a concept of anonymous functions in C++. So write that down. So anonymous functions. Let me spell this. Yeah. So anonymous functions let us see if I go. So anonymous functions allow us to define a variable, and then the variable has a could be called as a function. So that's kind of the cool part. It's like you could define a variable that acts like a function. So it would be like instead of doing something like this, it would be a bit different. Which is one of the cool things that you could do in Go. So most Go routines use a anonymous function. Cool. So let's learn about returns. Okay. So yeah, we learned last Saturday that you could return an exit code. So here is just reiterating the exit code themselves. So So this is for function return values. Okay. Yeah, so they're pretty much just going through it and figuring out like, okay, so we have now a new function that asks a user for a variable. Sorry, for them to enter a input by calling get value from user. But then here is not, since it's not returning anything, there's no, this here will always return 0 because we're interacting with 0. Okay, so yeah, so there is yeah, so here we're not passing anything to it, so that's kind of why it's doing that. Okay, so this one will be 0, and we just the return will be 0 here in that case. Okay, and pretty much the same way, return just returns the number 5 here. Sometimes I might end up breezing through this because I don't think we need to go through it a lot. We could do the challenge. Well, they fixed it here. Okay, yeah, so it returns, and you could also call the function inside of the value itself. Sorry, you could assign the function, you could call the function inside of an assessment. So you're assigning to number the return of get value from user. So that's what they're doing here. And then like most, some languages you could return nothing. Wait, so what there? Oh yeah, so they've been doing this before. So void just returns nothing. So if your function is not going to return anything, you use do void. So here it's saying it's going to return an integer. Here it's going to return an integer. In the case of this one here, which is just printing, it's just going to return void. So that's kind of what it's doing there. Okay, so the issue here, this function returns nothing, but you're trying to use it as returning. So that's why it fails. Okay, so yeah, so the main functions you always return if it fails or not. I guess there's a standard library that's, oh, there's a standard library that handles it for us. So we have exit successfully, exit. Wait, what is the difference between exit? Okay, and then means that the program. Cool. Maybe we should start using this. That will be interesting, right? So we could start using that new standard library. So include. So include. So I haven't set up any like auto completion for C++ yet. Okay, and this one will give us the exit code. So I guess it's easier for that you don't have to write it down, right? And it most likely will support different operating systems too. So it might support Windows too. In this case. Okay, so let's try that. So let's see what it starts. Yeah, so it's 0. And then if we change this to what was the other one? So if we do failure. And that will be a lot easier for us because we don't have to remember. Oh, failure wrong. Yeah, so we wouldn't have to remember the different exit code. So we just have to remember to use that standard package and library, and then we could just use it, right? So depending on the exit code that we want, we could just use that. So the other one that we have is this. Cool. So that will be helpful because like we don't have to remember what 0 or 1 does. We just have to remember that if we use if we fail and we return exit failure, it's gonna be like the correct status code that we want. So I wonder if also handles Windows too. Okay, so there is no way for us to call main. So main is the entry point for the program. So only when you run the program main is called. You cannot really call it directly from anywhere else. So you cannot do like another function you cannot call main. Okay, so yeah, okay. So if we reach failure to return a value from a function with a non void return type other than main will result in a undefined behavior. Oh, that's interesting. So I guess if I do int return value and I don't return anything and I just do int number and I do something like this, I call it. Okay, so and then if we want to return, if we want to print it out, so we need to do include. So most of the stuff that most of the library we used Saturday of last week, probably not gonna remember the name, so I'm gonna have to look it up from time to time. IO stream. So this one is the one we use to print things out, and we need to use. We're not gonna do that. So here we're gonna do. So we're saying we're gonna use this on the library. We're gonna do out, and we're gonna pass number. So let's see if this works. Okay, so let's see if that works. No, it's not bio. Oh, I missed semicolon. Okay, so we run it again. Okay, so the compiler itself is going to tell me that there's something wrong. So that's good. So in this case, the compiler is telling me that I'm not returning anything, but I'm assigning it. So there will be no undefined behavior here, at least in the compiler that I'm using. So I'm using Clang. Yeah, there we go. So that prints 1. So it wouldn't let me, like this behavior that is mentioned here wouldn't happen, wouldn't cause any issues because the compiler itself is checking for it. Okay, also if you try to do, if you return, so here it says if you return, let's say that you have, so you do have something like here, and you return online here, like line 7, that means that the code below here will never run. So that's kind of what happens in most programming languages. After you return, nothing else happens below that point, and that becomes just that code. Cool. And this is just illustrating good examples of using functions. So the goal of a function is to be able to make the code itself reusable. So you want to use functions when you are, instead of like copying and pasting at multiple times, you are going to use, you can use a function to figure out, to reuse a code as much as you can. So that's kind of the goal there, is to be able to do that. To be able to not copy and paste the code. So right now, or if you look at the example here, it's pretty much the same. Nothing changes. Well, the only thing that changes is the variable itself. So you have a y and x. But you could create a function that just takes, in this case here, like they did here, they have a function that takes an input, and then the input is asked from the user, and then that's returned, and then you can just use it over and over. Like you can use it multiple times. That means that you reduce the code itself. So instead of having 6 lines of code that pretty much do the same thing, you only have 3 lines of code that does the same thing. Yeah, so it follows the dry best practices, which is don't repeat yourself. So the goal will be do not repeat yourself. If you copy and paste the same code over and over again, you could just create a function that does that for you. So this is just a test. We are gonna just bridge to the test. Okay, cool. And then the next one is arguments. So I'm gonna save this file here and start a new one for params. Cool. So here we are gonna learn about parameters. So let's see. So we have a function. Yeah, so here is print double. So the goal here is to be able to print a number. Print double. So it's gonna print the double of a number, but it wouldn't work. It doesn't compile because number is undefined. Because number is being defined somewhere else. Then here. So the goal here is to pass a value. So if we do something like we're gonna use include and we're gonna IO stream and then I want to keep using the other standard library. So C standard library. So if you do C so I most likely for the remainder of while I continue learning, I'm gonna continually use this library here to handle exit code for us. Okay, so here I'm gonna create a new function which is just gonna print a value. So we are gonna do std the standard library, and then we're gonna do out, and we're gonna print out the number times 2, so we're gonna double it. Okay. And then here we're gonna take number, let's say int, and we're gonna just print it out. So here we could be like we could say double input. So we're doubling the input here. Okay, so that's one. And then the next function that I want to make is one that adds the for input value, and it returns a input. So here we're gonna do we're gonna create a new value here, and we're gonna call it input. We're gonna initialize it, and then we could ask the user for a value. So we could be we are gonna ask the user for a value. So we're gonna be please enter. So we're gonna say please enter a number, and then we're gonna call I think it's n. N? Yes, n. So we're gonna do n, and we're gonna set it to the input. Okay, so we're asking the user to enter number, so we're printing out the screen. Then we're gonna take that number, and we're gonna get it from the console, and we're gonna assign it to input, and then we're gonna return input to the caller, and then print value print. I'm gonna rename this one to print double. Okay, and here we are gonna do int, and we're gonna say number, and we are gonna input here. So whatever the return of input value is, we're gonna assign it here. And then we are going to take number, and we're going to pass it to print double. Okay, so again, so the tutorial here is just teaching us how to use arguments or parameters. So the idea is to be able to pass a value from one function to the next one. So that's what we're doing here. So we're taking the return of input value, then we're returning it on line 8, and then we are then passing it to line 11. Sorry, to print print double value, and then print double value is the one that is handling most of the work here. Okay, so we could compile this and see what happens. See if we have any errors. Okay, so we have some errors. Wait. Oh, wait. Did I undefined it wrong? I might have undefined it wrong. Oh, I did. So usually in Go, the type comes after the variable, the parameter name. In C++, it looks like it comes before. So you say the type before you define the value. Sorry, the variable name. Okay, and then I missed a semicolon. And I missed another one. Okay, I think I got all of them. Let's see. Nope. Yeah, the semicolons are gonna get me. Okay, so there's a warning. Non-valid function returns. Okay, so the issue here, so like it compiled correctly, but I got a warning. Here is that this is just not supposed to return anything, so it's supposed to be void. So if I run it here and I do 4, I get 8. So I should put a space here. Okay, and then I could just rerun it again. So 4, 8 double. So that's kind of how it will work. So that's kind of the cool thing about if you use something like if you use something like parameters for a function. Okay, so here, let's see. So parameters and arguments. Wait, what is the difference? Okay, so a function parameter is a value used in a function. Function parameters work almost identical to variables defined inside the function, but with one difference. They are always initialized with a value provided by the caller. Okay, so what is the difference between arguments? So I guess they're using interchangeably, which is okay. Okay, cool. So now, let's see how parameters argument work together. Oh, okay. So I guess they're calling these arguments, and then the params are just the ones inside of the function. Yep. Okay. Cool. That makes sense. So fixing our challenge program. Okay. So here they're going through it. They take the input of the user, then they're assigning it to. So this is kind of what we already ended up doing. The only difference is how they define when they initialize the input value. So I'm initializing it here, they're initializing it in after you print the user, which is interesting. Okay, cool. So number is being initialized by getting the user input, then the input of the user is being passed to print double. So that's kind of what we ended up building, and then just print it. Cool. And since we're not returning anything, we just need to return. We're just gonna make the return type void. So it looks like. Okay, so different like if you pass functions to as or arguments, they could be they might be called in different, and the order might be called in different types. So A or B could be called. So B could be called first, or A could be called first. So something to keep in mind. In here, it wouldn't matter because you're saying the order already. So the order of A will be the first one and B will be the next one because we're doing in sequence. Yeah, so if the order matters, you should just declare the variables. You should call the functions first and then pass them as arguments. If you don't care about the order, you could just do something like this part here. Okay, cool. You could do the same thing with addition. So yeah, so you could have multiple arguments that you could go through and then pass them through. Same thing with multiplication. And that's kind of how the different, like the different orders. Sorry, you could do like, you could have multiple functions. You could fit a function into a function like they're doing here. Because functions are evaluated and then the, as if a function is passed as a param, they're evaluated and then passed down to the as an argument. Cool. Okay, so we're gonna do global scope. So again, I'm just rushing through this because most of it is like I know most of this already. So I'm just gonna brush through some of these things. Okay, so this one's next part is scoping, which is like when can how the axis of a function is handled. So if the function itself could be handled in different ways, it will be able to do it. Okay. We're talking about lifetimes of variables and scopes. So the scope mostly is if you use brackets and you declare a variable inside those scopes. Inside of those brackets, the lifetime of that value is assigned to that scope. So that means that if you like, let's just create a new one so I could think about it more. So okay, so we are gonna just include, and we're gonna include our IO stream. Okay, so in here, so I think we saw this before, but you could do something like this. And then I need to include, I think these are C standards libraries, so that's kind of why it's named like this. Okay, so here we're gonna do exit. Okay, so if we do something like this and we declare, so we're gonna do int x, and we're gonna assign it to 1. Okay, and we are gonna just print that out. So if we do sce out, and we send x, that should work correctly, right? So if we compile it, we shouldn't get an error. Unless you miss a semicolon. Okay, so we get a message here, right? But then if we try to access x outside of the brackets, that shouldn't work and we should probably get an error. Yeah, we're getting an error saying that x is undefined, right? Because x is only defined in this scope here. So if I go here and I take x and I do 5, right? And then I run it again, I get 15. How do I get 15? That is weird. Oh, that is kind of weird. So I'm not sure why that happened. I think it's mostly because like the scope itself is. Wait. No, did I did assign it? The right one. Okay, that's 5. Oh, I know why. So this is the issue. It's because I didn't add a new line to it. So since I didn't add a new line, it's just appending it, and that's why it looks so weird. Okay, so let's do that. So I'm adding a new line here. Okay, so that's a new line. Better. Okay. So if I run it, it's gonna be 5, 5, right? If I go here and declare 5, add a 1 here, it's gonna be 1 and 5. Okay, so the thing that happened, what happened here is, since I'm isolating X here, I'm defining X again. I am not overriding this X here, right? I'm not overriding the 5. I'm only defining a new X value that is assigned to the scope here, and this is how the scope itself is isolated. That's kind of the cool part about scope. And then same thing with the functions. If you declare multiple functions and they have like X in multiple places, only the X, you can only access X inside of that function block. That's kind of the cool thing about it. Okay, so cool. So the values are also only in scope, are destroyed after it gets here. So when we get to this point here, when we get to line 9, this is where the X value is destroyed. So like how the way that the compiler, that the program knows when to release the memory for X is when it gets to the end of the block. In our case, we have 2X. So our first X is gonna be destroyed here when we finish the program. Our second X, which is this one here, gets destroyed when we get to line 9. So when the program gets to line 9, it's like X is not used anymore, so we should just release the memory that we're located for it. So that's one of the cool things. Okay, so and the way it does it is okay, so if it's the way that it destroys values is from the bottom up, which is kind of cool. Okay, so the above rule around creation, initialization, and destruction are guaranteed. That is, objects must be created, initialized no later than the point of definition, and destroyed not early than the end of the set of the curly brackets in which they are defined. Yeah, so pretty much what I said before. This is an initialization here, and the destruction happens before the last curly bracket. So before the last bracket, we are gonna it's gonna get destroyed. Yeah, so the lifetime will begins here. X is still alive, so X is still here, and X gets destroyed before the curly bracket. It's mostly how the scope works, right? So X is defined here, so the scope of X is attached into the main function block, and it will only be destroyed after main is now being finished executing. And it's only most of the time it's just called out of scope. So when X gets out of scope, it's gonna get destroyed. Cool. Right, so the lifetime of function arguments and params is a bit different. Because you're passing by referral, so you're creating a reference of A, B. So when you pass it to a function, so when you pass it to add, a copy will be created of those values, and they will be sent to X and Y. So X and Y will be created under the scope of add, and then they will be returned as an addition. Whatever the result of the addition is, it's going to be returned back to the color, and then X, Y are going to get destroyed. So the way it works is the last argument or the last param is destroyed first. So So that's what we're seeing here. So it goes y, x, because y was defined after x. So it goes in reverse order of when you initialize the values. Okay, cool. So, and then pretty much here is pretty much the same way. So a, b, so b was initialized first. It was created, initialized first. So it's going to get destroyed first, and then it goes IA. Yeah, and then when you call it, you get a copy of AAP to the function itself. Function separations. Yeah, so they're pretty much using the same kind of sample where x and y are the params or the functions are the same as the arguments that are being passed to the function itself. In this case, we are they're different, right? They're only in scope here. X and y are in scope here, and they get out of scope, so they get destroyed there. And then here they get out of scope down here, and they get destroyed. So that's kind of interesting there. Yeah, so when you do x and y in the main function, you're only saying it for the local. You're initializing them as local variables, and their scope to that block of code. So x and y cannot be accessed. If this was just B and C, you could not access x and y in here. So the lifetime of x and y are attached to the main function block. Okay, and then here, so it's pretty much the same. So they're defined there. So we're skipping over the quiz. So to summarize, the scope of a variable is depending on the block that it was initialized, and then how they're used. So if you have two nested scope, which is what we have here, you could definitely use the value defined at a higher scope, which is the case here. But then if you reinitialize the same value, it wouldn't override it, right? Because you're creating a new value, and then that new value that you're defining and initializing is now part of the scope here. One other thing that we could do is, if we don't define it, we could change x to be something else here. We could change it to 6. And that should do it. No, wait, I miss. Let me say semicolon. Okay. Cool. Yeah. So if you change the value inside of a nested scope, then the value itself is going to change outside of the scope, because you're not defining it. It's not taking ownership of the value. So the scope itself of the value is not changing. You're only changing, you're assigning a new value to it. So it was just going to update this one here, and then you get 6 in both places, inside of the scope and outside of the scope. Just because you're not defining a new one, you're just reassigning the value to it. So that's kind of cool. Go back to here, and make a note here. So that's kind of a cool part of a scope. So if you could reassign a variable if the scope nested. So if we nest the scopes like we have in this sample here, you could reassign the value. Okay, cool. And then moving on. Okay, why are functions useful and how to use them efficiently? Okay, so this is kind of like teaching functions to people. Um, so a function helps you organize your code better, your program. So that's kind of, instead of having like a function that is like 200 or 300 lines of code, you have like multiple functions that are doing a bit of work for each piece of that one function that you need to use. And the other part is that reusability, right? So it allows you to reuse code and keep up with the drive principle, which is don't repeat yourself. So it kind of helps you do that a lot. And then the next one is testing, which you could test each function by itself. So it makes testing a lot easier. It lets other people also use your code. So like if you have a function that does like ask for a user input, you could have other people using the same function. And then if you make a change there, it would also help their code to their code base will also get a change too. So like if you improve the performance of a function, everyone that depends on that function will get it. So it kind of helps you if you make improvements to the code, the improvements will be seen there as long as it's not breaking change to the function. And yeah, you could just you could do abstraction. So as long as you don't you could think of a function of like a way to hide the complexity of a logic that you're doing, and then not teaching the user what that logic is doing. So like if you're doing like a HTML parser, you don't have to tell the user like how you're gonna parse it. The user has to send you a input, so HTML, and then you send them back like the HTML parse already. So you don't have to teach them anything. In most cases, you don't want to leak the abstraction. So that's kind of one of the cool things about functions. Cool. So that's there. So one of the biggest challenges challenges for new programmers encounter besides learning the language is understanding when and how to use functions efficiently. Here are a few base guidelines for writing functions. Statements that appear more than once in a program should generally be made into a function. For example, if you are reading input from a user multiple times in the same way, that is a great candidate for a function. So yeah, so again, the drive principle, don't repeat yourself. So this bullet point here is trying to mention that. Code that has well-defined set of inputs and outputs is a good candidate for a function. So like for example, like the one we roll for just printing. So if we need to print, if we ask the user for a different value, so if we do something like this, right, and then we want to print it again, this becomes very helpful because we can just print it again. We don't have to repeat the code for printing, or we don't have to repeat the code for asking for a user input. So that makes it a lot easier for us to be able to do it. So if we enter 2, returns 2, and then we can do 10 and it returns 20. So, but I found an error. We should add a new line here. Wait. So the microphone is so in the way of like I cannot look down, which is a good thing. And I misspelled params, so we want to rename that. Okay, cool. Okay, then that makes sense. So the next one is white spaces and basic formatting. Usually formatting in white spaces help you like read the code better. So spacing is very important because you know when things end when they start. For example, here there's a white space, so you don't you get lost when you're reading this. So the way to think of it is like if you're reading a book and the book is full of white spaces between each word, and you don't know when a sentence ends and starts, which is kind of what is happening here. So like here their functions are being declared the same way, but with different structures. So like it's better to just keep your program very very formatted. Okay, so I've seen this before, right? So for formatting, sometimes people put the uh, brackets after in the next line. I've been following this one here because most languages that I have used start the bracket at the after the primes. For now, I'm gonna stick with the Google standards. So because this will take a bit more effort for me to get used to. And if I was contributing to a different code, to like a code base that was like already defined the structure, I will stick to whatever format they have. So if their format that they have is this one here, where you add the brackets on the next line, then I will use that one. But I'm mostly used to using defining the bracket, putting the brackets at the start at the same line as the function name. So I'm gonna just keep doing this one for now. And in most cases, yeah, if the code base has a standard, then I'll probably stick to that. So you could split things by using, let's see. The lines could be split by, wait, this is a really, I see. So you could split things under by just adding another, by starting another string. You could do something like this, and because you don't have the semicolon here, it's gonna break down to the next one. Okay, cool. I usually prefer this one here, where the stream starts at the same line in the same column that the stream on the top uses. Cool. Let's see. This is hard to read. And okay, so usually you want to keep the equal signs next to each other on the same column. Hard to read. Wait, why is this one hard to read? Okay, so the comments themselves. So mostly of the time, it's like the comments should be equally in the same columns too. So that's really good. Then the next one is spacing between comments. If there are spaces between comments. So the next thing probably that I looked into, maybe for next stream, next Saturday stream, is a way for me to add any kind of like linting or any like, yeah, I think linting will be very helpful for the editor. Or if I find a tool that lets me link my C++ code. Okay, so for formatting, we want to stick to using the Google standard for defining functions, which is just adding the bracket at the beginning, at the same line as the function name. So we're not going to be doing this. So the tutorial itself is going to continue using a new line for adding a new line, adding the brace out a new line. So we're not going to do that. We are going to stick to creating, like when their lines are too long, we are going to create some space in between them. This one here becomes a bit of a struggle, but I will try to keep it up, which is keeping the equal signs on the same column. On the editor, spacing between, like same thing for comments, so we want to keep the comments next to each other, under each other. And then if I do any comments, I will just create a new line. Cool. Okay, so forward declaration definitions. Take a look at it. Okay, so the way in C works, so C, like I think you have the same issue in JavaScript as well. So in C you have, sorry, C++ and C, Java. I think Go doesn't care. But the way it works is a function has to come before it gets a call. So in this case, in the example that they're doing here, the compiler will fail because it doesn't know what add is, so it's gonna fail and it's not gonna work anymore. It's not gonna let you compile the code because the add is being defined after it's being called. Usually you want to define them before. And there's ways to get this to work correctly by using something like a header file, but I don't think we have gotten to that yet. Okay, so yeah, so it's not gonna let us build it. When addressing compile errors in your programs, always resolve the first error, reduce first, and then compile again. Yeah, so if you get 5 or 6 errors, you always want to fix the first one, because if you fix the first one, the other 5 errors or the other 4 errors is just going to go away, most likely, because it will be caused by that one error. That's kind of what happens in most of the cases. Okay, cool. So yeah, so you have to reorder the function definition if you want to use, if for the compiler to work correctly. That's one option. And the other one is by using forward declaration. So forward declaration allows to tell the compiler about the existence of a identifier before actually defining the identifier. So I think this is a header file. So yeah, well, in this case, they're just doing it in the same file. So we can try that out. So we're gonna do forward. I'm gonna probably misspell this, so I'm taking here. Okay. Cool. So we are gonna include our handy include. So IO stream and our include C library, C standard, yep, and main, and it's gonna return success. So exits. Okay, and then here we're gonna do some addition. So we're gonna, yeah, this is day2. Thanks. Hey, how's it going? Yeah, this is day2. Day 1 was last Saturday. So some background. I usually do Go or Python. I'm mostly calling Go or Python. Mostly on the stream I've been doing Go. This is day 2 of learning C++. Since I have a bit of background on other languages, it becomes easier for me to just like breeze through some of these things. And yeah, I use Vim Vim is my main editor. There's some efficiency of me, like some things that I do, but I guess it worked, the job done. So I've been using it for about 4 years now, maybe 5, 4. I think it's 4. Okay, so what we're trying now is forward declaration. So the way it works is if we do, so we're gonna declare a new value, or if we do something like, we're gonna create a number, we're gonna find number here, and then we're gonna initialize it with addition, and it's gonna be 2 plus 5. Oops, plus 5. And then if we try from the sample, if we do and add, which takes a, which is an integer, and then it takes b, which is also an integer, then we're just gonna add them together. So we do a plus b, get an answer, and then we should compile it. Okay, cool. So I forgot. That's gonna happen a lot. Most of the like, there is no semicolons in Go or Python, so that happens. Okay, so yeah, it's gonna fail because add is being defined, is being called before it's defined. So that's kind of why you do that. So you don't. It depends on how you want to do it. So if you use something like names, I think if you use namespace, oops, sorry. I think if you use something like I think I saw it in the syntax before, namespace or something like that. Oh, my other completion is messed up. So if I use namespace, and I do something like this, I think this is how the syntax works. Then I could just use out like that. But what I've been doing lately, because I'm trying to learn the right way to do it, is that this works too. So you don't have to use using or you. So I think you're right. It's using. So using namespace, you don't have to use it as long as you do something like this, where if you want to use anything from the standard library, you have to say that you're going to use it for the standard library. So that's kind of how I'm been using it, and it makes it easier for people to know where the methods that I'm calling or the variables that I'm using are coming from. For example, like this one is a bit confusing because it doesn't have any namespace. So like, where is exit coming from? Exit success, is it coming from IO stream or is it coming from the C standard library? That's kind of the helpful part of using the namespace as when you're using the functions. If you start the functions by using like the namespace. So that's kind of the cool part about it. Okay, so since I'm trying the forward declaration here. Since I'm using the forward declaration, I need to define the function, like the input, the parameters of the function, so how the function itself is gonna look before. So if we want this program to work, I have to change it a bit. So I have to do add, and then I have to say that it takes two params. So it takes A and B, and then it returns. Cool. Thanks for the follow. Is hinge. Hope I pronounced it correctly. Okay, so so the way it will work now is that I'm telling the compiler, hey, add is not, I haven't defined add yet, but add is going to return an integer, and it's going to take two params. It's going to take A and B, which are both integers. And then when we get here, it's going to be like, okay, so I don't know what add is, but I know it takes two arguments, and it's going to return an integer. So number here is an integer, so this is what we're going to be returning, so that's right. And then 2 and 5 are integers, so that satisfies it. And then here, so when it compiles, it's gonna run this add here because it's the one that we define later on. So that will make it a lot easier. So you're kind of telling the compiler, hey, when you find this function, it's not defined yet, but this is how the signature of this function is gonna look like. Trust me. And then when the compiler gets there, it's gonna just be like, okay, so the types match, so let me move on. And then it doesn't do anything else after that. Just making sure that your typing is correct. So in this case, it just worked. So I didn't print it out, so here I'm gonna print it out by using our handy out. And then we do the number. And we add a new line just because it has confused us before. Okay. Cool. Oh, I misspelled. No. It's no. Okay, so maybe this is a good time for the... Yeah, so you see all of these errors, right? So we got a bunch of errors here and a bit of warning, but the issue itself is only one, right? If I fix that one issue, they should go away. Well, most of them should go away. So that's why you want to focus on the first one. So the first error tells me that number is undefined. So if I run it again, yeah, I get 7. So what we learned a while back is so this library, this C standard library, has specific variables for exit. So you can use, let's see if we can find it here. Yeah, so it has macros. So it has different macros. So it has one for failure and one for success, right? What it's doing, so instead of me writing, so you could write return 0, or if it fails, you could return 1, right? Because this is our main function. So our main function could return, hey, what I did was correct, so I'm gonna return 0, which means that it was successful. Or hey, you had an error, or hey, I couldn't finish because of some reason, I will return 1, right? The way that it works is in this standard library package, you have failure macros for failure and success, and it will handle the exit code for you. So that's the kind of what they do here. So it's a fancy way of me having to write 0 1. I think what it also does, it also lets me, if I write some code in, it might be able to handle the different operating systems, right? Because it's a macro. Let's see if I could find the code for it. Yeah, so it works for Windows 2. So if I take this same program and I run it on Windows, I'm not sure how Windows handle the different exit code. But if I use this macro when I run it in Windows, it will automatically it should just work because of how it's set up. It should just be able to handle that from that part. That's kind of the difference. The difference is just like exit success just means that it's gonna execute a macro depending on the standard library itself. So it all depends on where the compiler or how the macro for exit is defined. So we have exit successful and exit failure. Cool. Okay, so that's one. So that's kind of what forward declaration does. So forward declaration allows us to define a function, well, a prototype of the function that we're going to be using. So that's kind of cool. And I see people use header files. So I'm excited about using header files when they come around. So instead of defining it here inside of the program, inside of the file that you're declaring the code itself, you could declare it in a different file that's called header file, and then it just defines the different methods that you're going to be using there. So it's like forward declarations in a different file. Okay, so this works when defining function prototypes. Keep the params names. You could easily create forward declaration by using copy and paste on your function declaration. Don't forget semicolon at the end. Okay, so that's kind of what I was thinking too. So if you go here, yeah, this tutorial is really good. Okay, so if I do something like this, if you do exclamation point today, you could get a link to the website too, that I'm using. Okay, so here, if I run this here, the compiler is gonna, the compiler failing? No, yeah, the compiler is failing because it's not able to link the function itself is missing. The declaration of the function is missing. No, sorry, not the declaration. The declaration of the function is there, but the code itself is for that function is missing. So the compiler is complaining that it cannot link, so it cannot find. So it expects you to have the addition function, the add functions code declare, and be ready to execute it. It cannot do that, so it cannot link that declaration that you did to the code itself. So it's gonna complain like, hey, what you're doing is you're missing a function. So that is very cool. Okay, so moving on. So yeah, if you forget to add a function, the body of the function is gonna complain. The compiler is gonna complain itself. Declaration versus definition. So this is implementing it. This is initializing it. So with a given file, a function object type, or template could only have one definition. So you cannot have add. So it will, so that wouldn't work because you cannot reuse the class. Sorry, you cannot reuse names of functions unless you're doing some kind of overloading. Types, templates, inline functions, variables are allowed to have identical definitions in different files. We haven't gone. So okay, so there is one of the questions that I had is anonymous functions, which in this case are called inline functions. That's good. So we have those. Cool. So I cannot reuse names of the functions in the same file. And I cannot reuse names. I cannot redeclare variables. But in one of the examples that I use before for scoping, I did do that exact same thing. So here I had int x6. So what we're doing here is instead of like redefining it with the same name, is that these are different scopes. So you could reuse variables in different scopes themselves. So line 9 is a top scope. This is like an inner nested scope. So we could do that there. We could redefine it. Cool. For advanced users, functions that share identical but have different params are considered to be distinct functions. We discuss those in lesson 7. So chapter 7 is going to talk about overloading, which is cool. Cool. So it's going over declaration and things like that. So I'm going to breeze through this. Program with multiple code files. Okay, so I'm gonna have to breeze through this because I'm using a Mac, and second, I'm using a different editor. So most of these things will not apply to. But I'm still gonna just like probably read the best practices. So yeah, so we have multiple C programs. Add more. Okay, yeah, so this is where over declaration becomes very helpful. Is that if you have a file that has like that, so if I create a new file that's just addition here, if I do int add x, and so if I add them together, right? X plus y, and then I have another one that says, I'm gonna call it multiple. Okay, and then here I do and main, and then I'm gonna just bring our handy include, so IO stream, and then include our C standard lib, which has the exit code that we need. Okay, so here we're just gonna write return exit. So a bit more writing. That's the only thing. Instead of me writing 0, it's just me writing exit success. Yeah. So here, if I do int num, and then I say add 1 and 3. And then finish that, the 1 and 3, and I do then I'm gonna print it out, so I'm gonna do cd then cop, and we're gonna just print out number, and then we're gonna add a new line. I don't know why I've been struggling to find single quotes for a while. Okay, cool. And then we try to compile this. Let's see what happens here. Yeah, so it's gonna complain that addition is not there. Makes sense. So if we do this, would it be able to find it? So now you're adding the over declaration on top of the file. Okay, so now you cannot find it, so it doesn't know where to look at. Okay, so this is mostly because I'm using. Yeah, so there is also a side effect of using NL. So the side effect of using NL is that it flushes to the terminal. So it's very inefficient. So it's better. So it adds a new line, but it also flushes the value. So if you have a bunch of new, things that are like printing out to the terminal like this, and you use NL, it's gonna flush here. It's gonna flush here, and it's gonna just flush for all of them. So the issue that happens if you flush for all of them is that the terminal refreshes itself. So that's why I don't use it. The goal will be to just let the terminal refresh after you're done outputting to it. So that's one of the benefits of not using it. Okay, cool. So because I'm using Clang, I think I have to. Let's see if that works. Yeah, so I have to pass the files myself. Okay, so that worked because I'm using a different. So in the case of the writer here, it just worked because he's using the Xcode. Since I'm using the command line directly. Hey SSP, it's going very well. How are yourself? Okay, because I'm using a new line, I'm able to. Sorry, because I'm using command line. I need to tell it the different files I'm recompiling. So I have to pass it. So the forward definition works. If I only do this, it doesn't work. Just because the compiler doesn't know where add is. So I'm passing the add file as part of the list of files that I'm passing, so it should be able to find it, and this works correctly. And mostly it's because I'm using the clamp command directly. If I was using like some kind of editor like VS Code, it will automatically just append all the files that are part of the function. Sorry, they're part of the program. Cool. Something went wrong. There is plenty of things that could go wrong the first time you try to work with multiple files. I'm glad, SSB. I'm glad you're doing well. Okay, if you tried the above sample and ran into an error, check the following. If you get a compiler error about add not being defined in main, you probably forgot to add the forward declaration of the function add in main.cp. If you get a linker error about add not being defined, yeah, so that's kind of the same error we have here. And it's because the file is not being passed into the compiler and the compiler doesn't know where to find it, which is what we did. Cool. And it goes into like different ways to handle it. So the way for us, because we are using Clang directly, we just had to add the file name to it, the new file that we created to it. So that means if we continue using multiple files, we will have to just append them to the list of files that the compiler should look at. Okay, so that's pretty much a summary. So okay, so multiple files is kind of straightforward. You still use, this is where look forward declaration makes sense, is because you have to, if you split your program into multiple files like I did here, you have addition and then you have main. So maybe I should take this and make it into a different directory. So we are going to move our add function and we're going to put it here. And then we're going to take our multiple file and we're going to put it in here. And I'm going to just call it main.c. Okay, so here, okay, so that's kind of how it works. And the only change that I have to do here is that I'm calling it main. Okay, yeah, so that still works. Cool. So maybe if things continue going this way, we might start using multiple files for the next couple of chapters. Okay, so we learned about forward declarations of functions, and we just have to declare them on top of the file for now. So our main file is gonna always have like the functions that we're gonna be using from a different file. Cool. And that's pretty much it. Here they want us to split it, so it's pretty much the same basic. So you create a new file, call it input, and then you do a forward declaration of it. Okay, moving to name collisions and introducing to namespaces. So oops, sorry about that. I just bumped into the microphone. Okay, so namespace collision is what we were talking about before. Like in the case of some of the things I'm doing, we're not using something called use namespace. So you could do something like, cool, hey, Fratin one, thank you for the follow. I hope I'm pronouncing your name correctly. So we could use names space and then like sc. And then here, we don't have to use this anymore. I think I spelled that incorrectly, so I need to check what's the right way to use it. But if we do that, that means that we don't have to start when we want to declare a variable. Sorry, when we want to use a variable or function from a different namespace, we don't have to say the namespace. But the thing that I found was that it's very useful to have the namespace as part of like as part of the variable, because it makes it a lot easier to find. Okay, so that's kind of what we're going to be talking about next, is namespaces and how it can help with collisions. And in Go, you kind of get namespaces automatically when you do imports because of how the import library works. So we could look at some of these things here. So since we're doing some Go, so this is kind of how namespacing works, right? It's like if you want to access anything from syntax, you have to do syntax that you have to do syntax that and then the value that you want to access, or the structure you want to access. So this is kind of the same, but instead of that, you use comments. Okay, cool. So that's kind of what we're doing here, is that we're saying that we want to access cout, and then we're saying that cout is part of the standard namespace. So if you have like multiple variables that have multiple places that have something called cout variables that have, multiple libraries that have cout, right? We could just be like, okay, so is it coming from the standard library namespace, or is it coming from different namespace? So like this program here doesn't use namespaces, I believe. Cool. So namespaces. A namespace is a region that allows you to declare names inside of it for the purpose of this ambiguity. The namespace provides a scope, called namespace scope. So it brings back to scoping. So you could only access things inside of the scope when you're inside of the scope. Well, I take it back. So you could access things from outside of the namespace scope, but you have to say that you are going to access that by using the name of the namespace. Okay. Which simply means that any name declaration inside of the namespace won't be mistaken for an identical name in another namespace. So that's very cool. Enter, thank you so much for the follow. So the notification, there's a delay on the notification, if you guys haven't noticed, is because of how it's configured. We kind of build the whole streaming, like the headers and all different things ourselves during one stream. And we're now using webhooks or WebSockets. So there's a kind of a bit of a delay from time to time. So you might see the notification coming out in a bit, but I'm also looking at the dashboard, so that's why I'm able to see it before the notification goes up. Cool. Thank you so much for the follow. If you're enjoying the content, don't forget to press the follow button or subscribe. Okay, cool. Namespaces are often used in groups. Okay, so I skipped this part. Name declare in a namespace will be mistake for identical name declaring in another scope. Cool. With a namespace, all names must be unique, otherwise a name collision will result. Namespaces are often used for group related identifiers in a large party that helps ensure they don't advertisely collide with another identifier. For example, if you put all your math functions in the namespace math, then your math functions won't collide with identical named functions outside of the math namespace. So this is very useful, right? So it's mostly for isolation, right? You're able to isolate most of your code from other code that might collide. So let's say that I create a new stream and I call it exactly like this, right? cout. That means it will probably collide. So if I using namespace std, it's gonna collide. So it's gonna collide with the standard library unless I declare my own namespace. So we will see that in a bit. Okay, so there is global namespaces. In C++, any name that is not defined inside of a class, function, or a namespace is considered to be part of an implicitly defined namespace called the global namespace, sometimes also called the global scope. Oh, okay. So I'm not sure if this will work, but so these functions here, at least return value, is part of a global scope. That means that anything could call it without having to say like the scope of it. Also, I don't know if you're able to declare values like this. So if I do bar and then I do 5, in some languages, this is also considered a global variable. In this case, I'm not sure if that will work, so we will not try it for now. Okay. Okay, cool. So we have a global scope, which we want to avoid as much as we can for now. And then this is the scope that we've been using the most, right? We've been using the standard library scope, which has, we use the std prefix to access it. So that's kind of what we've been doing for the past, like, since day one. Cool. And this is a new operator. So before we learn about the multiple operators that we've used, so we have the what name? I think it's sender operator. So I know we have a reviser, a way to revise data, and a way to send data. So this might be the sender reviser. I kind of cannot remember the name of it, so I might have to go back and figure it out. Cool. Let's do that. So we're gonna go back to day one because I can't remember the name of the operator. I didn't write the names of them. So, oh, I know where. Did I write it here? No, I didn't write them. So maybe something to add up for day 3. Okay, I will make a note of that for day 3. Cool. So we are able to access a namespace by using the scope resolution operator, which is just colon, and use a specific namespace prefix to access identifiers defined in a namespace. Yeah, so here is a using namespace way, but then you don't know where CL came from because you don't have the prefix. So this will work correctly, but the issue now is like I don't know where it came from. So imagine if you're using like 5 or 6 different libraries in this file, you wouldn't know where it came from. So I will prefer to use standard. I will prefer to use the operator just because of that, just because it adds a nice prefix. So another way to access identifiers inside a namespace is to use a using directive statement. Here is our original hello world program with a using directive. So yeah, so you don't have to use the operator there. So this is the issue, right? So if you have a function, you name it the same way, what will happen here is that there will be a collision between your function name and then the function that was part of the standard library. And then the compiler complains because there is duplicate information. So we could do that. You could try that out. Okay, I just copy and paste that one just so we could see the error. In this case, we named the names. Yeah, so we have a collision between names because we don't know which one we want to use. Do we want to use the one that we just do we just want to use the one that we just defined, or do we just want to use the one that came from the standard library? Sorry, from the IO stream library. So which one do you want to use? So the compiler just doesn't know which one to pick, so it just refuses to compile, and you get an error. So that's why I usually in the languages that have like namespacing or like ways to isolate packages from each other, I would just always try to say use them as much as I can, just because of that. So I don't have to worry about like these kind of errors. If we rewrite this to taking this part out, and then I say, so this one will compile. Well, no, because I haven't really declared it. So this one will compile correctly. and then this one also compile correctly, right? Let's see. Oh, I spell count. That also happens a lot now, where cout turns into count. Okay, so if we do that, it works correctly, compiles, and then the function also gets executed for it. So that's kind of the thing that happens with the way that I will handle it. Yeah, so like that's kind of the reason why I was just stick with using the prefix for the namespaces, just because there is the name. It will make the name collations for yourself a lot better. Also, if I try this, it wouldn't work either. So because it doesn't know how to send data to it. But that's like the cool thing about namespaces. It's just like it stops you from having name collisions with the standard library or any third-party library that you're using. Even when yourself, if you have a big project that you're working on, you might end up naming things the same in different pieces of the code base. So very helpful. Okay, cool. Warning: avoid using directives such as namespace. Such as using namespace std at the top of your program. They violate the reason why namespaces were added in the first place. So mostly the reason is to stop collisions, so you end up with collisions. Okay, introducing to the preprocessor. When you compile your code, you might expect the compiler will compile the code exactly as you written in it. This actually is not the case. Okay, so the idea is going to be mostly around how the compiler does some optimization and some changes to the code itself. So let's see what it does. Okay. When the preprocessor is run, it scans through the code file from top to bottom, looking for preprocessors directives. Preprocessors directive, often just called directives, are introduced. Instructions that start with a number sign, so hash pound, and end with a new line, not a semicolon. These directives tell the preprocessor to perform a specific or particular text manipulation task. So note that preprocessors do not understand. So the preprocessor does not use C syntax. Instead, the directives have their own syntax. So they kind of have their own syntax for handling things. So what they're talking about is how you do include, and then you tell it which library you want to include. So that's a directive. So the include directive is a way to import libraries. So you tell it like which libraries you want to import. Oh, this is interesting. So I didn't know this. So when you use include, it just takes the code from that library and puts it at the top of your file. So that's the interesting. That's kind of interesting because I would expect them to be just like it wouldn't. Well, I guess that's the whole point, right? The whole point is that it's gonna go and look at the IO stream library and it's gonna bring everything and put it in your in the main file that in your program. But it says on the top of the program. So it says the preprocessor replaces the include directive with the context of the included file. The included content are then preprocessed along with the rest of the file and then compile. So it's just like it just takes whatever is in that file and puts it at the top of your file. Okay, that's interesting. When the preprocessor runs on this program, the preprocessor will replace include IO stream with the preprocessed contents of the file name IO stream. Since include is almost exclusively used to include header files, we will discuss include in more details in the next lesson. Okay, so that makes more sense. So it's not really importing the whole like implementation, it's only importing the header files. So the header files are the ones, so we were looking at forward declaration, so that's pretty much what a header file is in this case. from my understanding. Okay, there's macros, which we need to look into later, but let's see. Macros defined. So the defined directive can be used to create a macro. In C++, a macro is a rule that defines how input text converts into replacement output text. There are two basic types of macros: object-like macros and function-like macros. Function-like macros act like functions and serve as similar purpose. We will not discuss them here because their use is generally considered dangerous, and almost anything they can do can be done via a normal function. Okay, so function-like macros are out of the question. Object-like macros can be defined in one or two ways. So definition and identifier, and then substitution tags. Okay, so here, if we're declaring I think I should just create a file. So I think so from my understanding, when I was looking into C before, macros were dangerous because you couldn't determine the behavior of them. So depending on the compiler, or depending on, well, I guess depending on a lot of things, the behavior of a macro will be affected by it. So your function, if you use a function as a macro, the function itself could misbehave, and you will have a hard time to figure out why it's misbehaving, because it's all based on the compiler or the operating system that is running on. So here we're gonna do my name. Oh, okay. So that was the next thing I had in mind was like, well, a macro. So I missed the single quotes. Okay, so the way that I'm guessing this kind of macros work is just like doing a replacement. So it's gonna replace my name. It's gonna be replaced here, which is just a string, and it's gonna place it there. So see how that works. Okay, and then we're gonna return. And I'm gonna try to stick to using exit, the standard library for exit. So we are just gonna bring that one in here, and we're gonna do exit. And here I want to do our namespace. Then we're gonna do out, and we're gonna pass this here. Then we're gonna use our macro. What that does. And I miss a lot. I added a comma by mistake, and I missed a semicolon. Okay, so cool. So yeah, a macro is just mostly like templating. I think that's the best way for me to call it. So it's a way for you to templatize different cases. Like, I guess maybe there is a way for it to use macros. If there is a if else macro, then you could have a if else. If this is something, then define my name to something, to this, and then else, this is the default value for my name. Like, I guess that's how you use a macro. It's mostly to like doing like thanks SSP. Thank you for the hydrate. Okay, so cheers. Okay, so I don't know how macros are useful just yet. So hopefully we could get an answer for that. Okay, the preprocess converts the above into the following. Yeah, so it just does that. So that's what I was thinking. It's just like a templating language. So you could replace things in it, but it makes it difficult to know. I will hold my reservations on this for a bit. Okay, so we recommend avoiding this kind of macros altogether. Okay, so yeah, that's pretty much it. Which runs in print output. My name is Alex. Okay, and then it says we recommend avoiding this kind of macros altogether, as there are better ways to do this kind of things. We discussed this more in lesson 4.13. Yeah, so for me, it's like I don't understand why this is useful. So I kind of, this says it. Will avoid it because I don't know. Like I don't know why this is useful. Why not declare a variable and just pass it my name or something like that? Object-like macros without substitute text. Object-like macros can be defined without substitute text. So instead of doing passing Alex as the name, you just do my name and then something happens. Macros this form work like you might expect. Any further occurrence of the identifier is removed and replaced by nothing. This might be pretty useless and is useless for doing text substitution. However, that is not what this form of directive is generally used for. We will discuss this on this form in just a moment. Unlike object-like macros which to text, macros of this form are generally considered acceptable to use. Okay, so this is what I had in mind. So you have directives for if define, and then you can change different structures based on that. This is also kind of scary. But I could see how it's helpful if you have if you want to do different inputs and different outputs or different actions based on the operating system that you're in, or if you pass different build flags. So you could define, like, you could probably handle some of these interactions. Okay, the conditional compilations preprocessors directives allow you to specify under what conditions something will or will not compile. There are quite a few conditional compilation directives, but we only cover the three that are used by far the most here. So if defined, if it's not defined, and end define. And if. Okay, so that's kind of, this is what I had in mind when I was looking at this here. It's like, depending on the name, you could probably do different actions. But I wonder if you could use equal signs. So I wonder if you could compare things. The if define preprocessor directive allow the preprocessor to check whether a identifier has been previously defined. Is so the code between the if define matches and if is compiled. If not, the code is ignored. Okay, so in our case, print Joe is defined, so we are gonna print this here. If print Joe is defined, we are gonna print this here. So in our case, it's gonna print Joe. It should change this to Bob is gonna print Bob. So that's kind of what this thing is doing here. Same thing with if not defined. So that's interesting. So here, it's just gonna not print any of these things. Also, again, this is kind of interesting. I'm not sure what. This feels like I'm not sure how would I use this. Because I could just use a if statement, right? I could be like, if this is equal to but I guess this is, if you could set these kind of directives, you could define directives from the as compile flags. I could see how it becomes useful. Object like macros do not affect other preprocess directives. Now you might be wondering, fine, since we define print Joe to be nothing, how can the preprocessor did not how come the preprocessor did not replace print Joe with nothing? Macros only cause text substitution for normal call. Other preprocessor commands are ignored. Consequently, the print Joe if define print Joe, Joe is left alone. For example, foo here is a macro solution. If foo, this is foo does not get replaced because, so it's not going to replace it. So they don't affect each other. So macros, so I guess when you use directives like this, you could put them anywhere, and then it would just gonna run. So the function itself doesn't have to be called. Same thing for programs. Same thing for multiple files. It just gets created first. And since it's not defined, it's not gonna print anything. Okay, so that's interesting. I still don't know the use of this. So I'm gonna make a note of that. Yeah, I'm not sure how we use them. It seems like they will complicate things a lot. So yeah, so I want to research to see if there's a way for me to use it with the compiler that I'm using. If there's like any cool thing that you could do with them. So for now, I just feel like they're just gonna complicate things a lot. Okay, so we are doing header files. So header files is what I was looking forward to learning. Okay, so programs, as the programs grow larger and may use more files, it becomes incredibly tedious to have forward declarations. Forward declare every function you want to use that is defined in a different file. Wouldn't it be nice if you could put all your forward declarations in one place and then import them when you need them? So this is kind of where the header files come into play. Let's just read the insights. Header files allow us to put declarations in one location and then import them where we need them. This can save a lot of typing in multiple file programs. When you include a file, the content of the include file is inserted at the point of inclusion. This provides a useful way to pull declarations from other files. So what we learned before was that when we do something like include here, it's just gonna get replaced. So it's a macro that gets replaced with the content of IO stream, which is just a header file. Okay, so that's kind of cool. And then here is the same way, and we could declare our own header files to be able to do those things. So we are gonna start doing more. So I'm gonna make a new directory. Here I'm just gonna call it main. Okay, so pretty much the way it works is that we get a IO stream header file that we include, and then the compiler takes it and just lays it on top where it gets defined. So here, pretty much. Cool. So I don't have that command. So we ended up building the commands for a bot. I didn't add the time command. I've been streaming for about 2 hours now. But I will probably make that a command. So I'll make a note of that too. It'd be cool if you could do time and then get the time of the stream, how long the stream has been going on. So we ended up building most of these things, most of the tools for the stream. So like the alerts, the header bar, and then like as part of the stream, we ended up writing it in Go, like 2 months ago, something like that. So the alerts themselves and the commands themselves are driven by it. That's very late. So I am in the United States. It's only like it's pretty much the same time, but like PM. So it's only 2 p.m. 1 p.m. here. It's very cool. Thank you for watching the stream from Mongolia. Okay. So we're pretty much doing the same here. So instead of doing this, we're gonna declare a header file. So we just have to learn how to do header files. So we are gonna write our main program first. So okay, so we could do, and we're gonna include our IO stream, and we're gonna include our standard for our execute. So end main and return access. So right now we're not handling any errors, so I'm just always gonna do this. And I think here I'm just gonna do the additions. Yeah, so we are gonna access our standard out, and we're gonna call out. So we want to. Okay, cool. And I think from the sample, we just need to include things like this. So let's see if that works. So I'm gonna open first. I'm gonna open a new file for adding addition, and then here I'm gonna open a new file. And I'm gonna add a new file for the header. Okay, cool. And here I just have to do, we're gonna add the function itself. So we're gonna do it's gonna return an integer before. It's gonna take A, then which is an integer, then B, which is also an integer, and here. Then we're gonna return the addition, the result of the addition here. And then the header file, I think I just have to define it. So we are gonna define. So we're gonna just create a prototype of it. So we are just gonna define how it looks like. Yes, project. Wait, I missed semicolon. Okay, and here I'm just gonna add a new line. Okay, so and then save this one. Thank you. Yeah, I've been forgetting to do that. Thing happens to me in JavaScript too a lot. Okay, cool. So I think I might have to do something different. So let's try to run this. So if we do, so here we have to pass main and add. Let's see if this works. No, because addition is missing. So I wonder if this will work. Oh, okay. So first, what I'm doing wrong is how I'm including it. So I have to use, okay. So instead of using the angles, the arrows, I have to just do add that h. Okay, cool. So that's how you, so I guess you're declaring it like this here because these aren't part of the standard. They come with the compiler or the operating system. So they're standard libraries. And this one is not a standard library, it's just part of my own code base. So that's why you have to define it differently. Okay, so that works, but the compiler is complaining. So the reason it's complaining is because I'm passing. Oh, so I guess I don't have to pass it. So it will just automatically go and find it. Okay, cool. So I wonder if it's because of the naming. Oh, okay. So this makes sense. It's because of how I'm. So because of the name that I'm using here, it's going and finding it, and then importing it and replacing it. Okay, so that makes sense. Okay, so we now have header files. So it's very cool that we have them, because now we could declare the prototype of a function once and not have to import it. So that's kind of the magic of header files. We just have to include them every time we're going to use one of those functions. Yeah, so it gets compiled, and then so add gets compiled, and then we get an object and add that o. Then here main gets, so first IO stream gets inserted on top. Then because we have also C standard there as well, that also gets put on top. So those two header files are going to be on top. And then later on line 3 here, our add header file gets appended to the file because of how the compiler is doing it. And then we get a main IO main.o file. Then it gets linked together, and we get we get the main executor. So in this case, because we're using Mac, we get a.out. So we could rename these things to whatever we want. Or yeah, we could rename it, but for now, I'm just gonna leave as 8. Okay, cool. So this is kind of cool. Including header files is correct in the current, including a header file in the corresponding source file, which is what we did. Best practices. When writing a source file, include the corresponding header if one exists, even if you don't need it yet. What does that mean? So the one I've seen is this one here. So maybe if you get a compiler error, indicate that it's possible that the file could have been named something like add non-sanction add that text. So the ones I have looked at, the different code bases I've looked at have H because you have also C headers. So in C, you could also have header files. And the way to differentiate between a C header file and a C++ header file is by just putting pp at the end of the C++ header files. Okay, so this is kind of where I got tripped up, is the Angular brackets and versus quotes. You are probably curious why we use angle brackets for IO stream and double quotes for add.h. The answer is that angle brackets are used to tell the preprocessor that we are including a header that was included with the compiler. So that's kind of what I thought. So for us here, we're just saying that we don't want to use IO stream, which comes with a compiler. Same thing with C standard lib, which comes to the compiler. So we're using the Angular brackets, and then here we're just saying that we want to use one of our header files. So that's kind of the difference there. Cool. Okay, so let's see. So you should look for this double quotes tell the preprocessor that this is a user-defined header file we are supplying. So you should look for the header file in the current directory containing our source code first. If it doesn't find the header file there, it will check any other included path that you have specified as part of the compiler IDE settings. Okay, so in some cases, so I cannot look at all my environment variables, but in some cases there's an environment variable that you give the compiler, and then that with it will look for standard for libraries. So you could do that when you build like the kernel, the Linux kernel. You do that where you pass like some extra path for libraries. You can also do the same thing. You do the same thing when you're trying to build like Python from source. So that's very cool. Okay, why doesn't IOStream have a .h extension? Another commonly asked question is, why doesn't IOStream or any other standard libraries header files have .h extensions? The answer is that io.stream is different header file than io. Explain that. To explain that require a short history lesson. Okay, do I want to take the history lesson? Sure, why not? When C++ was first created, all of the files in the standard running time library ended in a .h surface. Life was consistent and it was good. The original version of cout and cin were declared in IO stream.h when the language was standardized by the ANCI committee. They decided to move all of the functions in the standard library into the ST namespace to help avoid name conflicts with user-defined identifiers. However, this presented a problem. If they move all the functions into the ST namespace, none of the all programs that included IO.h will work anymore. Oh, okay, so pretty much what it is for backward comparability, right? So if you use .h, you probably get you wouldn't get a header. Sorry, you wouldn't get a namespace. But if you do this one, you get a namespace. I guess that's the difference. Yeah. So yeah, so most of the libraries come from C. So most of the header, like, it's mostly to be able to keep some of the header files. Sorry, it's mostly so we could handle the namespaces. And if they start with most of them, if you start with .h, you might end up using the C version of the library too. Yeah, you shouldn't use extensions. So that's kind of the best practice, is not to use an extension there. And then the reason why we use it for ourselves is because there's no difference between ours and theirs. Okay, including header from other directories. Another common question involves how to include headers from other directories. One bad way to do this is to include relative paths to the header file you want to include as part of include line. For example, yeah, so I kind of had that issue when I was doing Node.js, where you try to do relative path, but in some cases it gets very funky, because if you're depending on where you are, the root of like the code could change, right? And then you just throw things off by a lot. Okay, so there's ways to do this. So I wonder if I could use that flag. So if you use -i, you could specify where the include folder are. So maybe we should try that. So let's try that. So I'm going to just create a new directory called include. Then I'm going to get rid of. I'm going to move the header file there. I'm going to move it to include. And then if I do something like I want to make sure it probably works. It should work. So if I do, I think the flags are almost the same. So if I don't include, but I want to make sure that that file that is there. So we have this add.h file. So I want to get rid of that. Okay, so that works. So we could include, if we use include, we could include the headers in a different path. And then the name doesn't change, right? So that would be helpful for some programs where you don't have to do any weird stuff. Like you don't have to do something like include and then slash like that. You can just do like that, and then we can just pass it as a flag, we could pass the directory as a flag. Okay, and I guess you could use many includes as possible. Header file might include other header files. Yeah, include the header files. So you could chain them. So that means that you could have a header file that if a function depends on another function, if a function depends on a structure that is in a different header file, you could have them like link them together. Each file should explicitly include all of the header files. Header files it needs to compile. Do not rely on header file included in transitively from other header files. Huh. I would expect the compiler to handle this for us. So what they're saying here is if we have 4 header files and the first header file includes IOString, we might not be required to include IOString. You should do it, but I don't think. Oh yeah, so the compiler doesn't do that. So if you have like 3 header files, one has IOString, the first one has IOString, and then some other ones depend on IOString, you don't have to include it again because it wouldn't let you. Sorry, it will let you, but it wouldn't tell you that there's an error, that you're missing it. So ideally, you want to be able to, you have to remember to do it yourself, and the compiler will not tell you that there's an error. Yeah, so this is the kind of the thing that is happening. Yeah, so for example, like that's kind of the issue that will happen. Order your includes as follow. Your own user-defined headers first, then third-party file libraries headers, then standard library headers. So in our case, we have it wrong. Wait, is that the header files? Oh no, yeah. So in our case, it's wrong. So it should be something like this. Okay, so first you own header files, then third party, then the standard libraries. But they haven't been doing that there, so interesting. Okay, always include header guards. So next lesson we will learn header guards. Do not define variables and functions in header files. Global content are sessions. We'll cover them later. So you could have global content values. Giving your header files the same name as the source file they are associated with. Okay, so we should always name things. The header file and the source code file should always be the same. So we have, in our case, we have our header file is called add in there, and then here is called add to. So that's kind of what they're saying there. Okay. Be mindful which header files you explicitly include for functionality that you are using in your code file. So mostly don't. So this one here is just saying like don't include things that you don't need. Same thing here. Every header file you write should compile on its own. It should include every dependency that it needs. Only include that you need. Do not include everything because you can. Do not include. Yeah, don't. I wonder. This is gonna just insert. I wonder if it's just inserts all the code on top. That would be very painful. Okay. Header guards. And so yeah. So it will like this is going back to the one before where we cannot define values with the same names. And here it's gonna fail. So what are header guards? So while these problems are easy to fix, the header file is quite easy to end up in a situation where definitions in a header file gets included more than once. This can happen when a header file gets included in another header file, which is common. Oh, wait, do I have to do that? So header guards. So, okay, so the thing that is happening is, I think I could reproduce it here easily. Okay, so we are going to create a new header. So the issue that happens is because we cannot reuse names. Oh, sorry, not reuse names. What can I do? Not multiplications. I don't know what to call it. I'm gonna call it some code. So some code, and then this code is gonna depend on our addition header. So we're going to include it there. And then this here is just going to do, our function is going to return something. Do I need to do that there? No. So here, it's going to take a, it's an integer. Okay, so that's pretty much what it's going to do. It's just going to take one single and then I'm going to include it here. So here, I'm going to create a new source file, so code C, and then I'm going to include some code here, and then I'm going to do, so here I'm going to do int some code, and it's going to take int, and it's going to be a, I put a back. So the issue is like the compiler is going to have a it's not going to work correctly because we are importing addition twice. So if I do return add, and I do a, and then here I do 5. Okay. And then here I could do oh wait, I don't need this. I don't have to import myself here. So I'm gonna take that and put it here. Okay, so we are going to try to trigger compile error, and then we're gonna try to fix it. So we have some code. Okay, so where's that? Some code. There. Oh, I call it something. Let's just we see the error back down here, but for now, let's see some code. We are renaming this to something. Something. Not a great variable names, but something here that should fix our error. Hey, something's wrong with our something. Oh, it's maybe because our error is happening on top. So on the bottom. So we have this error on the bottom here. I might be doing something really wrong. We have something comes from something. Not the best names. Not the best names. Okay. Then here and some. So we have something here. Maybe I should just call it some code, but call something. There's some kind of addition. Oh, it's because I'm not including it. So yeah, there we go. Oh, and I'm passing 2 values, right? So it's trying to overload. So that's kind of why I cannot find it. Why that happened? So it's trying to overload. So here, get rid of. Okay, so this is the error that it's saying is because in one of our header files here, we're including addition, and then our main program is also including addition. It's complaining that it doesn't know what to do. That the addition function is being duplicated, and then you have to use the guards. So what the guards are doing is that you take, where's the guards? Yeah, you take something unique here. But that's kind of that is interesting. Okay, so we do that and it should just work now. Hey, join combo, how's it going? Okay, so the guards themselves are supposed to protect, like stop you from, like stopping the compile from adding it multiple times. If something is not defined, then it's going to find it and then it's going to add this portion here. So that's what the addition one is doing. But then it somehow ended up breaking our, oh, I see. So the issue is that this one here doesn't go. So the goal is to only include the library once, like to define the only ones. There we go. Yeah. But this feels a bit weird because you have to define it over and over again. And this is how they do it here. So you have to, the way you would do it is that you have to define a value. And usually, so it looks like they use the header name. So they use the header name as the value, and then they use that to see if they have to redefine the header file again. This is an issue with if you have ever done PHP, this is a big issue in PHP, where a class can only be defined once, but if you import it multiple times, you end up with this condition like this, and then you end up like having to set up some guards like we are doing here. So I wonder if namespaces help with this. Probably not. Updating our previous example with header guards. So header guards are just adding a macro using the preprocess of if it's not defined, then define it, and then you add everything in there. And then you could just import things like this. So this one is importing it. So you have like the geos, geometry stuff, headers, then you import it here, another different header, and then you use it as a guard. Okay, so that's kind of what the guards are being used for. It's mostly just to protect it from redefining the same thing over and over again. So they will be included multiple times. So it doesn't stop us from including the code over and over again, but it stops us from the code executing, like the header is being the forward declaration is being declared multiple times. So kind of good. Okay, so so if the compiler supports it, we could just use this here, the pragma once. Since the certain persons, so if we do that, that means that we could just use it. So we just need to check if our compiler supports that flag. So if our compiler supports that flag, we could that macro, we could just use that macro. So it does look like it's supported. So we could just start using it there for ourselves. So let's see how we could use it. Okay. So do you put it in the header? Well, that would be the only thing. It's like, where do you put it? Okay, so they recommend you stick with adding the guards yourself instead of using the macro, because there's no guarantee that the macro itself will be supported by the compiler. So if our compiler doesn't support it, that means that it will break. So this is very specific to the compiler. So we should just stick to using guards, defining the guards ourselves. Okay, that makes total sense. So we're gonna do this one, and I think then the summary of the chapter, and I will end this, yeah, and then I will end the stream there. Cool. So first step, define your goal. The other two reps, yeah. So I think it's just gonna walk us through writing our first program from scratch. So let's see. Ideally, you should be able to state this in a sentence of 2. So if you're writing a program, you should be able to say what you're doing, you want to achieve in a couple of sentences. So that's pretty much what it's doing here. So allow the user to organize a list of names and associate phone numbers. Generate random dungeons that will produce interesting looking elements. Generate a list of stack recommendations. So you kind of define what you're doing, then define the requirements if there's any requirements. Define your tools, target, and backup plan. So it's pretty much walking you through, like, if you want to write your own program from scratch. Clean the house, clean the backend. So right now it's just going and teaching you some fundamentals about the programming. But it hasn't asked what it wants us to do. Okay, so I think this is the first program designing. Okay, so it's designing our first program. So it just went through like the necessary steps to design a program. It doesn't mean that we have to write one ourselves, which is kind of interesting, cool that it's going through that process. So if you are watching, you should go and do this part here. I'm just gonna skip it over because there's a lot of content. But it's mostly of how, the necessary steps to break down the problem. And then when you break down the problem, you then start thinking about how you're going to implement it in code. And then you figure out like the necessary tools that you need to achieve your requirements. So you think about requirements as well. And then you implement a bit of it, and then you test it and make sure that works correctly. And don't make your code look perfect. Start. Okay. So we learned about functions and function calls. We learn how there is different scopes depending on the function. We learn about status codes, which we've been using in our main program. So we've been using exit success as part of it. We have learned about function params and arguments. We learn about scoping and the lifetime of variables. Most the scopes is defined. The lifetime of value is defined based on if it's still using the scope or not. So if it's out of scope, it's gonna get destroyed. Refactoring, we learned a bit of that. Forward declaration is a way for us to declare a prototype of our function, because in C++ you have to declare your functions before you use them, and forward declaration allows you to define the prototype of your function, but it doesn't force you to write the call of that function. Like, you don't have to implement the function fully. You just have to implement like what is returning and the arguments that it's going to be taking and the types of the arguments. Definitions. Declaratives are, I believe, is just like the macros. So you could define different macros, and you could define different preprocessors, which is handles like includes, just takes the content of the include file that you're including and adds it to it replaces it. So mostly of replacing. I think that's pretty much it. Cool. So I'm gonna end the stream here. Thank you so much for watching. I will be doing chapter 3 next week. And yeah, this was fun.